Alrighty, so we are adding in reflections and phase shifts to what we've already done. So as far as the transformations go, we've done A, B, and D. We're throwing C in there today. So I put up here again like the full everything with A, B, C, and D. But we're going to talk just about what C does. Now C does the same thing C has done on all of them, which is translate it left or right. It's just not called a translation or even a horizontal shift in with one of their trig functions. They're called phase shifts. But again, they do the same thing. X still lies. So if it's plus C, we're going to the left C units. If it's minus C, then we're going to the right C units. So that kind of stuff doesn't change. So let's look at our translations here. So I have on number 1, f of x equals the cosine of x plus pi. So this is my x plus c, and then this is the plus d. So that would mean here I'm going to go to the left pi and then up 1. Okay. So even though we're just talking about c, it does say the translations, and that 1 is a translation. Number 2, if you look at that compared to what it looks like here, notice these are just x minus c, both of those, not anything multiplied by x. And if we look up here, when I do have b, which is something multiplied by x, it's factored out of that. All right, so that means here, before I can answer that question, I need to factor it out. So this becomes f of x equals the cosine of 2 times x plus pi plus 1. After that b is factored out, that's when you get to look at c. So that means here I'm still going to the left pi and up 1. So numbers 1 and 2 actually have the same transformations. The only difference really between the two is that your frequency is 2 in the second one. Okay, everybody okay with that? You have a question? You sure? Okay. Sometimes I can't tell. It's easier without your mask. I can tell when you look at me like that. I'm like, what? No, I'm just looking in the eyes. I misjudge that sometimes. Okay, so number 3. We have the sine of x plus pi halves. Do I need to factor anything out? No, right? So then this just tells me that I'm going to go to the left pi halves. And that's it. Do I need to factor anything out in number 4? Yes, and it's whatever's in x, that's what I'm factoring out. So this is going to become f of x equals the sine of 2 times x plus, and then let's think about what has to go there. Pi over 4, very good. Because I'm not factoring out 1/2, because everybody wants to say pi there most of the time. You have to think about what you're really dividing both of these by 2 when you factor it out. So when you divide that by 2, you get pi fourths. Then once it's done, if you want to double check that you did it right, when you distribute this back in, when I multiply 2 times pi fourths, I should get this number, and I do, so I'm good. So then this tells me that my translation, which direction am I going? Left. I'm going to go to the left, pi fourths. That's my transformation. We good? Or my translation, rather. All right, so y'all go ahead and do 5 and 6. Playing video games over there. All right, so on number 5, when I factor this out, what does that leave me with inside of here? 4 pi. Very good. So this is 4 pi, which means my transformation is that I'm going to the right 4 pi. When I factor the 3 out here, what do I get right here? Pi thirds. Very good. Which means I'm going to the right pi thirds. Okay. Any questions at all? So just remember, you got to factor for that and make sure you don't do something weird. Yes, ma'am. Oh, it's also down to, thank you, yes, and it's also down to. Yeah. Anything else? Thank you for actually saying something and correcting me, because not all classes always do that, and then I go on, and then somebody has a question like at the end. On number 4. All right, so let's look at number 5. We're going to graph this, and so the only thing this one has here is a phase shift, right? But we're still going to fill all this stuff in here. I think I still left the directions weird, like, yeah, graph it, then identify, but really you have to do this first. So our amplitude is 1. Our frequency, which is B, is 1, because there's not a B there. The period, well, since the frequency is 1, it's 2 pi. My phase shift, which direction am I going? Left. So I'm going to go to the left, pi halves, and my midline is y equals 0. I'm still going to draw in my parent function. These are even more important now to keep up with which points you've plotted. I also draw in my midline. Okay, so a lot of what we've done so far, I've said multiple times, there's no horizontal shifts, so this is what it's going to be. So now we have those horizontal shifts, so we have one more thing we need to think about. This point right here, if there were no horizontal shifts, it would be at my midline 0, 0, no matter where the midline is. Well, the midline's at 0, so it would be here. But there is a horizontal shift. Instead of the point being here, I have to go to the left, pi halves. That's where this point is now. This should be at the end of the period, and the period is at 2 pi. So I can put my pencil, my stylus, whatever, at 2 pi, but then I have to shift to the left pi halves. There's the end of the period. Then from there, I can really just do half, half, half and figure everything out. But so I can either count to figure out half, or I would know that since this is 2 pi, this is at pi, so I could go to pi and then also move over pi halves, and that works too. Between these 2 points, I go up whatever the amplitude is, and it's 1. So between these 2 points, I go to 1. Between these 2 points, I go to -1. There are my 5 anchor points. And then I just repeat those to fill in between -2 pi and pi. So this would be here. This would be here, here, here. And then I can sketch it in. And once you get it sketched in, what kind of graph does it look like? A cosine graph. So if I gave you the graph and all I said was write an equation, you could write this one, or you could just write y equals the cosine of x. Both of them get you there. We could also write it with some other translations or whatever and still get the exact same graph. However, when you're given the function, there's only one graph you can get out of it. But remember, all that cosine is a translation of sine anyway, so that's why it looks like that. Okay? Any questions? All right, so let's look at number 6. I'm going to need to factor, so I'll go ahead and do that. F of x is equal to the cosine of 2/3 times x minus what? Pi. That one was pretty simple, right? Okie dokie. So our amplitude here, still 1. Frequency is now 2/3. So what is the period? 3 pi. Remember, you take 2 pi, either divided by the frequency or multiplied by the reciprocal, which would be 3/2, so you get 3 pi for your period. Phase shift, we're going to go to the right pi, and our midline is still at 0. This is a cosine graph, so here's my cosine parent function. Midline, y equals 0. Okay, so from the parent function, I would be at 0, 1, or 0, midline 0, whatever the amplitude is, which it's 1, unless there's a horizontal shift, which there is. So I'm going to put my pencil or my pen or stylus at 0, 1, bless you, and then I have a phase shift of pi, so I'm going to move to the right pi. There's my point. The end of the period is 3 pi long. Well, 3 pi is off my graph, and if I have to translate to the right more, clearly that's way off, so that doesn't really help me any. Halfway between 0 and 3 pi, right here, I'd be at 3 pi halves. I can get to 3 pi halves, it's right here, but when I translate over pi, I'm off my graph again. So that point doesn't really help me either. Am I going the wrong way? Oh. Then halfway between these two, this is what? What would that be? Remember, don't make this harder. If this is 3 pi halves, this is half of that. That's just 3 pi fourths, right? You just multiply by 1/2. I can get to 3 pi fourths. It's right here. And that would be a midline 0. And then I need to move to the right pi. If you're not sure where to jump pi, remember you're counting by 4. So you can go 1, 2, 3, 4, and you're here at pi. So I can only get 2 of my 5 anchor points on there. But that's really enough, okay? Because everything is evenly spaced, and you should be able to think about what's going on here. My parent function would have moved to here to look like this. So really it's just doing the same thing backwards. And so I skip 2. If I'm already up here, when I skip 2, I got to be down back here at 0. Then I'm going to skip 2, and I'm going to be down at -1. Skip 2, back at 0. Skip 2, back at 1. So the fact that it repeats and it's periodic makes it easy to see the pattern even with just 2 points. If you know if you understand where you are in the graph, and that's why it's important to have this for you to refer back to think about what pieces you actually have on there. What questions do you have? And to me on this one, when you look at this, you don't necessarily feel 100% like it's sine or cosine since nothing hits the axis like it would. And really you could write the equation as either one if you were writing an equation. That's why it usually says write an equation, not the equation, because you have more than one option there. All right, any questions at all? Okay, so the next thing we're going to do that we haven't done yet is reflections. And we already understand reflections, so there's not any like little lesson to it. You just know that they've got a negative there, right? This negative, when it's being multiplied, means you have a reflection. Would that reflection be in the x-axis or the y-axis? X, because it's affecting y. If it was going to be a reflection in y, then it would be in here with the x. Does that make sense? Okay, so it's going to be a reflection in the x-axis. I didn't, on these 2 reflection ones, I didn't put in any phase shifts, so this is exactly what we've been doing, just plus a reflection. So our amplitude here, remember that's the absolute value of A, so this is just 2. Still just 2. Frequency, 1, so your period is 2 pi. There's not a phase shift, and your midline, y equals -3. Sine parent function looks like this, and I sketch in my midline. Okay, so this would be a midline 0, 0, as long as there's no phase shift, and there's not, so this is a midline 0, 0. Then this is the end of the period, still a midline 0. It's at 2 pi, so it's 2 pi from here, I'm here. And then halfway is pi. So there are those 3 midline zeros that I get from here. From the parent function, I would go halfway between the 2 up to 1, but that changes to my amplitude. And since there's a reflection, I'm not actually going up, I'm going down 2. So between these 2, I would go down 2. And between these 2, I would go up 2. Those are my 5 anchor points. Any questions about why I did anything or where anything came from? All right, so then I just repeat that over here. This is up here and down here. And just so that you understand that these graphs could have more than one function that represents them, instead of this equation being this graph, I could have written it as a sine graph that has a translation instead of a reflection. Like we could have translated over pi and just had a sine without a reflection. That would work too. Or it could be a cosine with a translation, or a cosine with a translation and a reflection, like whatever. There's lots of options there, okay? Any questions at all? All right, so let's look at number 8. Amplitude, absolute value of A, so that's 3. But I'm going to circle this negative so I don't forget to do it. Frequency is 2, so the period is pi. Phase shift is 0. Midline y equals 1. Just fly through that because hopefully by now you can find that stuff pretty easily. Here's my cosine. Here's my midline. Okay, so I want you to go ahead and get your 5 anchor points on there. I'll give you a chance to get started before I do mine so that then you can then double check yourself before you fill in your whole graph. So once you get your 5 anchor points, then check yourself with me. And if you agree with me and don't have any questions, go ahead and finish the graph up. Any questions on number 8? Good? All right, so 9, 10, and 11 are kind of everything all together. A, B, C, and D plus a reflection. You could have any or all of the parts of that. So a couple of things I want to look at first. I've got a negative, so I'm going to circle it. And I need to factor B out. So this is going to be f of x equals negative 3 times the sine of 2 times x plus what? Pi halves. Good. And then minus 2. So my amplitude is a positive 3. My frequency is 2. So the period is pi. Okay. I don't know why I can't. Oy. All right, so period is pi. Phase shift, which direction am I going? Left, bless you, pi halves. And midline, y equals negative 2. We always just write in the midline. Okay, so, and that's a good question. let me draw in the midline, then I'm going to address that. So we've got the sine. This is the parent function, and then I'm going to draw in my midline. So her question was, don't we also go down to? And the answer to that is yes. But the midline takes care of that for us. Since we make the midline the new x-axis, that down to, that's not anything we have to count anymore. We just use that as the axis, and it's all taken care of. Okay? It's a good question. All right, so 0, 0. An amplitude doesn't affect that. A reflection doesn't affect that. The only thing that affects that is a shift left or right. Okay, so I would be at my midline 0, 0, but I'm supposed to go to the left pi halves. So I go to the left pi halves. That's this point right here. Then I'm going to go to the end of the period. The period ends at pi, and it would be a midline 0, but I have to go to the left pi halves. That's the end of my period. And as long as I have the beginning and the end of the period, and I understand what my parent function looks like, the rest of it is just half, half, half. Halfway between these two is another midline 0, right here. Halfway between these two, I would go up whatever the amplitude is, but there's a reflection, so instead of going up, I would actually go down 3. So between these two, I would go down 1, 2, 3. And then between these two, I would go up 1, 2, 3. So those are my 5 anchor points. Once you've got those on there, you just repeat them. Any questions on how to get to any of that or anything at all? Alrighty, so we'll just finish this up then. Any questions on number 9? Okay, let's look at number 10. So I need to factor. There's no reflection, so I get f of x equals 2 times the cosine of 1/2 times x plus what? 2 pi, and then plus 1. So my amplitude is 2, frequency 1/2, which makes the period 4 pi. I'm going to go to the left 2 pi, and my midline, y equals 1. So we'll go ahead and, well, I'm going to have you get the 5 anchor points on there, and then I'm going to talk you through my thought process of getting those 5 on there. Maybe it's the same, maybe it's different. As long as you can do it, it's fine. It's your midline. So go ahead and get your 5 anchor points on there. I'll give you a minute or so to do that, and then I want to talk you through it. And I may have already said this in here, but one thing I do like about you doing some of these things on Cami is it makes it very easy to switch colors. And I don't care that it's colorful. You do everything in black and white. That's fine. But I think it is helpful to have like the midline in a different color because it's, then it doesn't make your graph look weird and confuse yourself or whatever. Okay, so here's how I would come about these points. Oh, I totally drew. Oh my God. I hope you didn't follow this. Nobody corrected me. Is that what I should have drawn right there? Oh my Lord. Sorry, guys. So if you made it a sine graph because I drew that, I'm sorry. If you noticed it and didn't say anything, shame on you. Fix me when I mess up. Okay. All right. So for my parent function, this would be at 0, 1, or on here it would be my midline 0, whatever the amplitude is. So the amplitude's 2. A reflection would affect that. I don't have a reflection, but I do have a translation. So instead of being at the midline 0, 2, I then have to go to the left 2 pi, and I'm way over here. Okay. The period is 4 pi, and that's off my graph, but if I'm over here at 4 pi and I move to the left 2 pi, I actually end up here. You can think of it that way, or just find a distance of 4 pi from this one, and so I go 2 pi, another 2 pi. That's where this other point would be. I have the beginning and the end, so halfway between these two, from the midline, I go down 2. Halfway between these two, it's a midline 0. Halfway between these two, midline 0. And then it's just pretty stretched out. Excuse me. And I could, instead of writing this equation as a translation, I could have written it as a reflection, because that's kind of what it looks like, but again, there's options there. Any questions at all? All right, so then I want you to do number 11 from scratch on your own. So if you want to check your anchor points before you move on to graph the whole thing, I'll leave mine at the anchor point spot here for just a second. I left my anchor points pink in case I did that too fast. You needed to see where my 5 original ones were. But there we go. Any questions at all? All right, so today's assignment on Delta Math, I don't think there's any phase shifts on today's assignment at all, because there was only one section in Delta Math that had it, and I didn't like the way they did it, so I didn't assign that. So today's assignment is a lot of what you've been doing, but with reflections in it now. And then Monday, you're going to graph, basically like 9, 10, and 11, where it just kind of has them all in it. And so I just decided to go ahead and talk about phase shifts and reflections today because I could get it both in one day. And then that's on Monday, you're kind of just doing a hodgepodge of everything. Does that make sense? That's why there's not going to be any video, because basically you have the lesson, you have some graphs to look back at, and then it's just going to be practicing in Cami on that. Okay? Any questions at all about any of it from any of you? Okie dokie. So then